This video will introduce and highlight the core characteristics and effectiveness of Duravi catalyst. These tests highlight the power of Duravi's cutting-edge catalytic alloying and atomic rearrangement (CAAR) process. Lubricating oil abrasion and wear resistance test. In this test, we subject a test specimen, steel cylinder bearing ball, to a steel contact surface at high-speed rotation to evaluate their interaction. This analysis allows us to measure two key parameters: the coefficient of friction, which quantifies the resistance encountered when one surface slides over another, and the wear volume, which assesses the amount of material loss due to this frictional interaction. These measurements are crucial for understanding the durability and performance characteristics of materials under applied stresses and meet CE, ASTM, CQ, and AFM standards. Stage 1, control test, non-lubricated, surface-to-surface contact.
Everybody see where that's at. You see the heat on that surface. As I apply it, what happens? Goes right up to weld.
Results are measured when the two surfaces achieve surface weld or exert enough pressure against each other that they begin to bond locally at their points of contact. Stage 2, high-performance synthetic gear oil. HP synthetic gear oil is applied directly to the rotating surface.
No additives inside. So watch. See the heat? See the heat?
The slight reduction in initial stress and the subsequent minor increase in time to weld, TTW, are observable along with the results of petrolubricant breakdown at weld. The smoke produced is evidence of lubricant components superheating and breaking down into corrosive and often toxic sludge. Stage 3, Duravi catalyst. Duravi catalyst is applied directly to the rotating surface in the previous high-performance synthetic gear oil.
Look at this. I usually don't drink of it. All right, now listen close. Impressed? Pretty impressed, huh? See the heat, yeah. Try the heat again. Now comes the crazy part. What am I doing? I'm increasing the heat. Why would I be doing that? Remember in the very beginning I told you I wanted to increase the heat? All right, I'm doing what's called induction hardening now. All right? But what's happened? I've stopped the wear.
With the slight addition of Duravi, the contact surfaces continue to interact without achieving weld, even as the HP synthetic lubricant continues to burn away and break down. Through the CAAR process of Duravi, the contact surfaces maintain significant reduction in coefficient of friction and wear abrasion even without the primary protection of the petrochemical lubricant. Stage 4, Duravi stress testing, extreme condition simulation.
The longer you keep it in there, the more pressure that's put on it, the harder the alloy. And I'm going to prove that in a minute. So watch. For every second that I hold down on this, I'm cutting a micron of metal away. So is it going to seize? Yes, but I want to see how long. Here we go. I want a micron of metal is a second. So here we go. 1, 2, 3, 4, 5, 6. We went deep with one touch. You can use anything as a carrier. Anything as a carrier. Listen.
This test demonstrates the inherent characteristic of Duravi to achieve a reduction in friction and wear in extreme conditions, such as a solvent bath. The solvent bath simulates total loss of the conventional, boundary, and/or fluid pressure lubrication regimes in a system. It is notable that Duravi achieves this delivery of function even without another lubricant regime within the system. And as demonstrated by the solvent bath, just about any liquid delivery agent can be used as a carrier for Duravi. Stage 5, Duravi stress tests thermal stability and resistance.
It's all over, isn't it? As I push down, it gets more oxygen. Can I get the picture? Get the point?
This test demonstrates the inherent thermal stability and resistance to heat even through catastrophic system failure, as simulated by the application of sudden high heat and flame. Stage 6, Duravi stress test, friction-induced heat load.
All right, here we go. How hot are we?
This test simulates single-component pre-failure due to extreme high. The application of extreme high heat simulates the drastic rise in operating temperature for insufficiently lubricated and/or failing components. Duravi surface technologies are applied and improved through the application of heat and pressure via the tribological reactions happening at a molecular level. Every application of Duravi you have observed in this video has not only increased lubricity of the system, it has also exponentially increased the surface hardness and corrosion resistance of the contact surfaces.